Example 78. So we're looking for the probability that a standard normal random variable is between negative 2.05 and negative 1.65. Okay, so let's do our drawing here of a bell curve. I'm making it a little bigger this time because we're going to need some space on just one half of the curve here. Okay, so I'm going to put 0 in the center. Remember my z-score here, number line, right, is what's underneath it. And I want to think about where these two numbers are located. Well, negative 6.1, or negative, 1.65 is to the left, obviously. And negative 2.05 is a little further to the left, right? Remember, negative numbers, the more negative they are, the further they go out to the left. So I'll put a line here and a line here, right? Just to indicate where those two numbers are on the curve above. Now I'm looking to find the area between these two numbers. Remember, if your statement here in the middle is between two values, it means you want to find the area between those two numbers. We're literally looking for the z-score values that are less than this number, but bigger than this number. Less than this number, but bigger than this number. That's the shaded area I've just shaded. Now remember what we have to do. We're going to go to our table and we're going to look up these values. But before we go there, what will we get if we look them up? Well, if I look up negative 1.65, I will get the area from the number I look up until the center. That's always what the table gives me. And if I look up this number, I will get the area from the number I look up all the way to the center. Again, that's all the table can give us. Now look at what we get here. This is a bunch of stuff we don't want. We don't want this white space here. We want the shaded space, right? This number gives us everything we want and then extra stuff we don't want. So the problem is neither value gives us exactly what we want. However, if you look at the drawing, you might see what we have to do. This is everything we want plus extra that we don't want. But this is exactly the amount of extra stuff we don't want. So if we take all of this distance and we subtract off this amount, we should be left with just from here to here, which is ultimately what we're looking for. So what you want to remember is when your two numbers are on the same side of the curve and you're shading in between them, remember this little rule, same side subtract. So it's triple S's. Do you see that? Same side subtract. So if the two numbers you're looking to find the area between are on the same side of the curve, you will subtract the numbers from the table to get your answer. And that's what we'll do here. So let's go to our chart and look up these two values. Okay, so we're looking for negative 2.05 in this column. I'm going to have to move the table up a little bit so we can see that row. So there we have it. We have the 2.0 row. We're going to go over to the sixth position, which corresponds to 2.05. Remember, we don't have negative, so we're looking at positive 2.05. It's the same answer. So 2.00, 1, 2, 3, 4, 5, and we get the answer 0.4798. Okay, so after looking at the 2.05, we got 0.4798. 0.4798. Notice how I wrote it across the shaded and white space because that's where it covers, right? All right, let's go back to the table and look up our 1.65 now. Okay, so we're here to look up negative 1.65 now. So we'll move the table down a little bit so we can see that value. So there's the 1.6 row. We're going to go over to the sixth position where the 1.65 number is. So there's 1.60, 1, 2, 3, 4, 5. We find the answer to be 0.4505. 0.4505. Okay, so we found 0.4505, 0.4505. All right, now that we have the two numbers, remember we're going to subtract them to find the answer we're looking for. So the probability that we're between negative 2.05 and negative 1.65 will be equal to the difference of those two numbers, 4798 minus 0.4505. 8 take away 5 is 3, 9 take away 0 is 9, 7 take away 5 is 2, 4 take away 4 is 0. So we get the answer 2.93%. 2.93%. That is the probability that we're between these two negative values on the standard normal chart.